In this second video on probability, we're going to look at what happens when we have two kind of separate events, or independent events as we call them, happening. So I'm just going to chat a little bit about the most kind of straightforward example, which is using a coin, and then we can develop it into different things like beads in a bag and the chance of different things happening and what outcomes we can get. But let's just take, for example, let's take a fair coin. So we've got two sides to our coin. We've got heads and we've got tails. Okay, just a normal coin. Okay, and on one flip, you've got the probability of getting a head is a half, and the probability of getting a tail is a half. Okay, so there's not much that can happen after one flip. But if you flip the coin again and again and again, then you get lots and lots of different overall outcomes. Okay, so from one you can be heads or tails. If you're flicking it twice, you get two heads, or a head and a tail, etc., etc. So that's what we're going to look at. And the best way of looking at these kind of questions is to use a tree diagram to help you understand what's going on and to make sure you don't leave any potential outcomes out. So let's say we're flipping a coin twice. Okay, so two separate events. There's the first flip, and then there's the second flip, or the toss, whatever you want to call it. Okay, so on the first flip, there are two possible things that can happen, and only two. Either you get a head, or you get a tail. Okay, there's no other outcome possible. And if it's a fair coin, which is the one we're discussing, it's a half chance of getting a head and a half chance of getting a tail. So we start to create this, what we call a tree diagram. These are like branches of the tree. You write the probability of the event happening on the branch, and then you write the outcome at the end of the branch, like heads or tails. Okay, so let's go back to the start. Let's say we flip a head to start with. That means we're going down this route. If you flick a head, we forget this route because that's a tail to start with. Okay, but then we're flipping the coin again, completely independent event. Okay, completely separate. But on that second flip, the same kind of thing happens. Either we can flip a head, or we can flip a tail. Okay, and again, it's a half chance of flipping a head, and a half chance of flipping a tail. Okay, that's what happens with two flips. So you can get a head, then another head, potentially. Or you could flip a head first, then a tail second, and you'd be following this part of the tree. Okay, so it all depends on what you're asked to do in the question. Okay, here we've not asked a particular question, we're just looking at what happens and how we build up a picture of what goes on. If you flip a tail first, that means you're going down this route. If you flip a tail first, then you pick the coin up again, you flip again, you have exactly the same outcomes again. Either you can flip a head over, or you can flip a tail over. Okay, and again, the coin is fair, so it's a half chance of that and a half chance of that. Okay, and they're all the possible outcomes. There's no other possible outcomes. Either I can flip a head, then another head, that's this one. I can flip a head first, then a tail, that's this one. Or I could flip a tail, then a head, well, that's that one. Or I could flip a tail, then a tail, that's the very bottom one. Okay, and they're all the different possible outcomes that you can get from flipping a coin twice. If we introduced a third flip, then we'd have branches from each of these. So third flip, head, tail, head, tail, head, tail, head, tail. And all of a sudden there's a lot more outcomes because obviously you're doing something a lot more times. You could get head, 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 or head, head, tail, etc., etc. Most of the time they'll probably ask you two routes, but sometimes they might ask you for three different routes. But hopefully that makes logical sense. If you want, you can try get a coin out yourself, flip it, and you will get one of these outcomes. They are all the outcomes possible in this question. You can't get a head, then a torso, whatever. It's got to be a head or a tail, hasn't it? They're the only outcomes that you can get. If you're doing it twice, either you can get head, 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 tail, tail, head, or tail, tail. That's it. Now that we know the different outcomes, we also have to think about the chance of those outcomes happening. Okay, and this is where we work out probability slightly differently to the previous video because we've got two separate events. In the last video, we were just looking at spinning the spinner once. Okay, and you're looking at like getting a 3 or a 4, you can add the probabilities. For this, because they're two separate events, we multiply the probabilities, two independent events. So the probability of getting a head, then another head, this top row, I'll get rid of the ticks now. The probability of getting a head to start with is a half. And the probability of getting a head again is a half. So the chance of you getting a head and another head is going to decrease. Because you need two things to happen. You need to get a head the first time, and then you need to get a head the second time as well. So you're asking for more things to happen. Not like when you're just doing it once and you're asking for, is it A or B or C, and you add the probabilities together because you're increasing the outcomes. Here, you're multiplying the probabilities because they're independent events. They're separate from one another. Same here, probability of a head and a tail is a half for a head and a half for a tail. Actually ends up being the same. And you'll notice the whole way through this, because it's a coin and because it's fair, all the probabilities of each different outcome, that's all of them there, all four of them, they are all the same. Okay, and we should also notice, we've talked about before, these are all the possible outcomes. So the chance of one of those things happening is 100% going to be one of those things. Either it will be head-head, head-tail, tail-head, or tail-tail. It can't be anything else. So there must be 100% chance, and that's our probability of 1. So all our probability of these happening should add up to 1, or sum to 1, and they do. A quarter plus a quarter plus a quarter plus a quarter is definitely 1. So it kind of makes sense. All these things have to add up and check out, and they're good ways of checking that you've done the answers right. So when we have separate, independent events, a coin flip, get the coin again, flip it again, there's two separate events happening there. So we multiply those probabilities together to get the outcome of both things happening. Okay. If you're looking at, some questions might say, what's the probability of getting two heads in a row? Well, that's going to be the top one. If they say the probability of getting a head or a tail, it's a little bit different, because a head or a tail, well, I can do this in either order, so it's both of these. So you're more likely to get a head and then a tail, or a tail and a head, so a head or a tail, than you are to get two heads, because there's two different ways of getting there. It can't just be head-head. You could have head-tail, or you could have tail-head. These amount to the same final outcome. It's just the order which is different. There's only one way of getting this. Okay, so this hopefully starts to make a little bit of sense, and you can think about it logically. And we're going to look at taking beads out of a bag, different coloured beads, lots more outcomes. It's the same kind of principle though, but they're the kind of questions we're going to look at in this section. But hopefully the overarching principle there you understand, and you can take that into this first question that we're going to look at. Okay, so let's have a look at this first question. So a little bit different to the coin flip, but it's the same kind of principle. So a bag contains 4 black discs and 5 white discs. You'll want to copy this out and write it down. You can write the full question out if you want. That'd be a good idea as well, and draw it out. But hopefully you can see what's going on here. So a bag contains 4 black discs and 5 white discs. There they are in here. 4 black, 5 white. Ranjit takes a disc at random from the bag and notes its colour. He then replaces the disc in the bag. Ranjit takes another disc at random from the bag and notes its colour, and then complete the probability tree diagram, and then ask you a little follow-up question. Okay, so very similar to heads or tails. In this question, we can either pull a black disc out or a white disc out, and you can actually visualise yourself doing this, and that might help you to see what's going on. So imagine you put your hand into this bag, and you pull out at random. You're not looking for a particular colour. In total, we got 4 black discs, and we've got 5 white discs. So in total, we've got 9 discs altogether. So when we do our probabilities, the chance of pulling a particular disc out will be over 9. Okay, the chance of pulling a black disc out is 4 over 9. 4 out of 9 are black, that's the chance of getting that. And the probability of pulling a white disc out is 5 over 9. So previously we've looked at decimals for probabilities, but in this case it makes a lot of sense to look at fractions. It's very easy to write the fractions down very quickly. You just write the number of discs, the number of the type of disc you want. So if I want black discs, there's 4 of them. That goes on the top, over the total number of discs, which in this case is 9. That goes on the bottom. And the same for white, there's 5 white, 9 in total. It's a 5/9 chance of pulling out one of those coloured discs. So completing our probability tree diagram. So the first disc, our first kind of pull, the chance of pulling out a black disc are 4/9, so we write that on the branch. And the chance of pulling out a white disc are 5/9, so we write that on the branch. We should probably write it on the answer line, but there isn't much room. So that's 5/9 and 4/9. Okay, just because there's 5 white discs, 9 in total. 5/9 chance. 4 black discs in total. And 9 black discs and 4 black discs and 9 discs in total, so 4/9 chance of being a black one. Outcome at the end of the branch, probability on the branch. Now there's some important things to look out for in these questions. If you've taken that disc out and left it out, if you think about what happens if I've got 4 black discs and 5 white discs. Let's say I'm going down. Let's say I pull a black disc out first. I'm going down this route. If I pull it out and leave it out, that's going to change everything in this question. Because now there are only 8 discs in total. There's still 5 white, but there's now only 3 black if I leave it out. So you have to read the question very carefully as to whether they put it back in or whether they leave it out. And in this case, it's probably a little bit easier because he is replacing the disc in the bag. So this sentence here, he replaces the disc in the bag. So every time I take a disc out, all the probabilities go back to where they started. Nothing will change because all the discs are exactly the same as originally. If it says he does not replace it, then when he takes one out, like a black disc, bang, there it goes, it disappears. And that's going to change all the probabilities, so you've got to pay a bit more attention to what's going on. Okay, but he doesn't. Anyway, let's get back to our tree diagram. So, black, then white. Let's say you pull a black disc out first. Well, the next time you pull a disc out, again, either it's going to be black, and it's good to keep it in the same order they have it in, or it's going to be white. And because you're replacing the disc in the bag, all the probabilities will be the same. So I've taken out, I've recorded its colour, put it back in. The chance of pulling a black disc out is the same. It's 4/9 because there's 4 black discs in there, and the same for the white. It's 5/9 because there's 5 in there. And if you pull a white disc out first, so say we're going down this route now, then the second disc we pull out, again, can either be black or it can be white. And again, the probability will be the same. If I pull a white disc out first, 5/9 chance, I'm putting that disc back in, and then I'm taking another disc. Well, there's going to be back to the same. There's going to be 4 black discs, so 4/9 chance of getting a black one, and 5/9 chance of getting a white one. And there's my probability tree diagram. It's 4 marks. It's not too bad, but you just got to pay close attention to how the question is worded. And this now makes sense, because if I'm pulling 2 discs out, either I can get black then black, black then white, white then black, or white then white. There are no other outcomes for pulling 2 discs out. That covers all bases. Calculate the probability that Ranjit takes 2 discs of different colours. So now you just need to look at these different outcomes here and decide, well, which of those outcomes give me 2 discs of different colours? Well, black then black, that doesn't give me 2 discs of different colours, I get the same. Black then white does, 2 different colours. White then black does, 2 different colours. White then white doesn't. So I'm concerning myself with the probability of pulling out a black disc then a white disc, and the probability of pulling out a white disc then a black disc. Excuse me. So probability of pulling out black then white, we always multiply along the branches. Chance of getting a black times by the chance of getting a white afterwards, 4/9 times 5/9. You got calculators, but top times top, bottom times bottom. And white then black, white is 5/9 times by black is 4/9. So I'm just working my way along the branches for each one. Again, this is going to be 20 over 81. And both of these outcomes are desirable. They're both the ones I want. Both of them result in 2 discs of different colours. So because there's 2 ways of getting there, I will add these probabilities together. Because both of them give me the correct result. So I'll get 40 out of 81. That's a nice final probability. Just leave it as a fraction. And that's the first example. Next video is going to have a few more examples, but I'm running out of time on this one.